Okay, imagine this. You're trying to aim a tiny laser pointer at something like incredibly small, maybe the size of a coin,
Okay.
but it's hundreds of thousands of kilometers away.
Max far.
And you're doing it in the middle of the day with the sun blazing. Sounds, well, basically impossible.
So it really does. The sun just washes everything out. But that's pretty much what we're talking about today, isn't it? A recent achievement that feels almost like that.
Exactly. We're doing a deep dive into something quite remarkable reported out of China. They've apparently managed to do laser ranging, bouncing a laser off a satellite way out in Earth-Moon space.
And the kicker is they did it during the day.
Yeah.
Successfully.
Yep.
That's being reported as a world first.
A world first, yeah. So our discussion today is based on the reports covering this breakthrough, placing it in the context of, China's wider space ambitions.
Mm-hmm.
And our goal, really, for you listening, is to unpack why this is such a big deal, what makes it so hard, and what could it mean for future stuff, like, say, building a base on the moon.
Right. Because it definitely seems to connect to those bigger plans. So let's get into it. The core achievement. Chinese scientists, daytime laser ranging, Earth-Moon space satellite. That world-first claim is pretty significant.
It absolutely is. Laser ranging itself, well, we've done that before, haven't we? Even off the moon reflectors.
Oh, yeah, for decades. Apollo missions left reflectors up there specifically for that. But daytime, that's the monster challenge. You've got this faint laser signal coming back.
Like vanishingly faint.
Exactly, over that huge distance. And it's completely swamped by sunlight. Solar interference is the technical term, and it's a massive hurdle.
Yeah, the reports we looked at really hammered that point home, overcoming long-standing technical challenges posed by solar interference. It's like trying to hear a whisper next to a jet engine.
Which naturally makes you wonder, how did they do it?
Good question. The sources don't exactly hand over the blueprints, do they?
No, not the specific how. But the fact they mention conquering these long-standing challenges, well, that points to some serious innovation. We're probably looking at things like much better lasers, maybe, or super sensitive detectors.
Could be filtering too, right? Really advanced ways to filter out that solar noise.
Definitely. Sophisticated data processing has to be part of it. Maybe a combination of all those things. Whatever it is, it worked.
Okay, so they cracked a tough technical nut. Why does it matter, though? Beyond just, wow, science.
This is where it gets really interesting and links back to those bigger ambitions. The reports directly connect this capability to China's plans for a moon base.
The one they're aiming for by 2028? Chang'e 8.
That's the one. Think about building something complex on the moon, maybe using robots. You need extreme precision, knowing exactly where everything is.
Like surveying, but, robotic and from a distance.
Precisely. Laser ranging gives you that.
Yeah.
And the reports mention this base will be power hungry. They're even talking small nuclear reactors for it.
Wow, okay. And there's talk of robotic infrastructure being tested, watched over by the Queqiao relay satellite.
Mm-hmm. And this daylight ranging capability could be absolutely vital for guiding those robots, placing components accurately, navigating the terrain, especially if you could do it any time, day or night.
Makes sense. So tell us more about Queqiao. It's already up there, right?
It is. Launched back in May 2018. Its main job was, and is, to act as a communication bridge for missions on the far side of the moon.
Because the moon blocks direct signals from Earth to the far side?
Exactly. It's tidally locked. Queqiao sits out at the Earth-Moon L2 point, a kind of stable spot in space, allowing it to see both Earth and the lunar far side. It was crucial for change of 4.
That was the first ever soft landing on the far side, wasn't it? With the Yutu-2 rover.
That's the one. So Queqiao is already a cornerstone of their lunar infrastructure. This new ranging ability potentially adds another powerful tool to its toolkit.
Right, moving beyond just talkback radio to super precise GPS almost.
In a way, yeah. It enhances control and situational awareness.
Okay.
And this all builds on the change of program's history. It's been quite methodical.
Yeah, they started with Tiandu-1, just an orbiter, right?
Correct. Then Tiandu-4 on the far side.
Yeah.
Then Tiandu-5 brought back samples.
Which was a huge achievement in itself.
Absolutely. Each step building on the last. It shows a very clear long-term vision for the moon.
And laser ranging just generally is fundamental to all that deep space stuff, isn't it? Measuring distances with incredible accuracy.
It really is. It's essential for calculating orbits, performing maneuvers, maybe even mapping resources eventually. That precision is key.
So being able to do it during the day, does that just mean more opportunities? Like they don't have to wait for night?
That seems to be a major advantage, yes. Imagine you need a critical course correction or need to guide a rover precisely. Not being limited to nighttime windows, either on Earth or the moon, could make operations much more flexible, faster, more efficient. It potentially opens up the operational schedule quite a bit.
Okay, that makes sense. And all this is happening within, well, a pretty big and fast-moving Chinese space program overall.
Oh, definitely. It's one of the world's most active. They have independent human spaceflight capability. Only the U.S. and Russia can also say that.
And it's managed by CNSA, their space agency, but also involves the military, the PLA, Strategic Support Force.
That's right, which signals its strategic importance. And the range of programs is broad. You've got the manned program, their own navigation system, Beidou.
Like GPS, but China's version.
Exactly. The whole lunar program we've been discussing and missions further afield like Tiandu-1 to Mars.
They're not stopping there either. I saw mentions of long-term goals like space-based solar power.
Yes. That's a really ambitious one. They've talked about demonstrating technology for huge solar power stations in orbit, first in LEO, then GEO.
Wow. Okay, assembling kilometer-wide structures in space. You definitely need super precise tracking and positioning for that.
Absolutely. This kind of laser ranging, especially in daylight, seems almost tailor-made for managing the construction and operation of something that massive and complex. Any slight error could be catastrophic.
Good point. And how does this fit internationally? Are they working with others or mostly going it alone?
It's a bit mixed. There has been some cooperation in the past, like the Double Star mission with ESA, some early work with Russia.
And there are restrictions too, aren't there? Particularly from the U.S.
Yes, U.S. policy generally restricts NASA and other agencies from bilateral cooperation with Chinese state-linked space entities. So a lot of what China achieves, like this daylight ranging, is done independently. It really highlights their growing capabilities.
Okay, so wrapping this up, this daytime laser ranging feat in Earth-Moon space, it's not just a technical curiosity.
Not at all. It's a major technical step forward, overcoming that huge solar interference problem. And it looks directly relevant to their moon-based plans, robotic operations, maybe even future mega projects in space.
It really makes you think, doesn't it? This ability to measure so precisely under such difficult conditions across such distances. What other really tough space exploration challenges might suddenly look a bit more, well, reachable? It's something for you, the listener, to ponder.
Definitely. If this has caught your interest, the tech, the moon missions, the whole idea of setting up shop on another world, there's so much more to explore about the Chang's program, China's space efforts, and what a future lunar base might actually look like. Plenty to dig into.
10 key points on Tiandu-1 daylight laser ranging breakthrough. 1. Tiandu-1 is the first satellite to achieve laser ranging in Earth-Moon space during daylight, overcoming the traditional limitation of only performing such measurements at night. 2. Daylight introduces intense background noise, making it extremely difficult to detect the faint return signal from a satellite over lunar distances. The success demonstrates advanced filtering and signal processing capabilities. 3. This breakthrough allows laser ranging to be performed at any time, not just at night, greatly increasing the frequency and flexibility of orbital data collection for lunar missions. 4. The achievement is likened to hitting a single hair from 10,000 meters away, highlighting the extraordinary accuracy required to target a fast-moving satellite across 130,000 kilometers of space. 5. This advancement provides crucial support for upcoming deep space missions by enabling more precise satellite tracking and navigation. 6. Tiandu-1, launched in March 2024 alongside Tiandu-2 and Queqiao-2, is part of a broader mission to test and validate new communication and navigation technologies for future lunar infrastructure. 7. The satellite is equipped with a Ka-band dual-frequency communicator, a laser retroreflector, and a space router, enabling high-reliability data transmission and precise ranging experiments. 8. Tiandu-1 and Tiandu-2 operate in formation in lunar orbit, about 200 kilometers apart, and have demonstrated stable communication, navigation, and data relay capabilities. 9. The mission's results will guide the design of future satellite constellations and lunar research stations, aiming for seamless Earth-Moon communication and navigation services. 10. The daylight laser ranging success marks a significant technological milestone, strengthening China's position in deep space measurement technology and accelerating progress towards sustainable lunar exploration. And swerve from perplexity. pplx.ai/share